Okay, so first thing we're going to take a look at is what Mr. Roy and I call the survival guide. So it's really just kind of some basic stuff that's not really in the book. It's kind of stuff that would come before the book, maybe stuff you did in like 7th and 8th grade, just to kind of refresh your memory, like PEMDAS and things like that. Okay, so we'll kind of go through and I'll tell you guys what you need to fill in as we go. All right, so the first thing says a blank is a symbol used to represent an unknown quantity. Does anyone know what we use in algebra to represent something we don't know? Yep, Seamus?
A variable.
Yeah, a variable. So the first thing you want to fill in on that blank is a variable. Is a symbol used to represent an unknown quantity. Can someone give me an example of a variable? Yeah? X. X is one we use a lot, especially when we do graphing. X comes up a lot. When we do graphing, there's another letter that comes up a lot.
Y.
Yep. So we use X and Y. But really, a variable can be any letter. Letters you might want to stay away from, the letter O. Why do you think the letter O could be confusing if you write that? Like if I just go like this and say, oh, that's a variable. Yeah?
Could be confused to be 0.
Could be confused. Yeah, it looks like a 0. Maybe an L could look like a 1. So we generally just pick any letter. X, Y, M. M's a letter that comes up a lot. Does anybody know where that letter comes up? Yeah?
Slope.
When we talk about slope. So when we talk about slope, if you've done y equals mx plus b, there's all those letters we just talked about. Y, M, X, I didn't put B, but that's another example of a variable. So under examples, if you want to write down a few of those letters, you could put those in. All right, so the next thing is a little bit tricky. It's two words. Let's start with the first one. So the first one, it's a form of the word for the name of the class you're in right now. So what class are we in right now?
Algebra.
Algebra. So the first blank, it's algebraic. And the second word, it's kind of hard, I'll just have to give it to you, is expression. So an algebraic expression is defined, you already have this part written, to have something that contains one or more variables and usually one or more operations. Well, we know what variables are. We just talked about that right there. Those are letters. But how about an operation? We're talking about doing surgery, or well, what's an operation in math? Yeah?
Plus, minus, multiply, divide.
Yeah, so the 4 basic ones are, add, subtract, multiply, divide. So an algebraic expression has a variable, and usually, I don't know why we accidentally wrote that twice. So it has a variable, and usually one or more operations. So someone give me a variable. Any variable. M. So there's a variable. Now give me an operation. Yeah?
Times.
Times. So there's different ways we can do times in math. Dot is one way. We generally stay away from using an X, because an X might look like a variable. Okay? We can also use, does anyone know what else you can use for times in math? Another symbol?
An asterisk?
That's kind of like the dot. We usually do it as a dot, but yeah, it's kind of like that. We have to use 2 of them. Yeah?
You can put parentheses.
You can put parentheses. So if you want to do multiplication, you can put it in parentheses. If you don't put parentheses, then it just looks like the number 98. Doesn't look like multiplication at all. So you can put parentheses or the dot. Either way, it depends. And now let's just pick, something else. M times 5. That's an example of an algebraic operation. It's got a variable, and it's got an operation. Okay, here's, make it a little bigger. Here's another one, X. Just X usually contains. Doesn't say it has to. So technically a variable by itself is still an algebraic expression. But usually it has an operation in there, kind of like that's kind of like the one we just did. 2x squared. X is your variable. Wait a minute, what's the operation? 2x squared. We didn't really talk about this yet. Yeah?
Being multiplied.
Yeah, it's being multiplied. So you might be like, well, wait a minute, I thought when you said multiply, you have to put a dot or you have to put a parenthesis. No, there's a third way. If you put a number in front of a letter, that always means multiplication. Okay? How about this 2 up higher? Does anybody know what that's called? Yep, Ellie?
Like squared.
Yep, it's squared. And what's that an example of? Like if you square something, or cube something, or anything like that? Yeah, Donovan?
Exponent?
An exponent. Okay? We don't have to write that down right now, but that's what that is. That number up higher is an exponent. Okay? So this one is multiplication. Let's look at the next one. 5 plus y. What's 5 plus y an example of? What operation is in that? Yeah.
Addition.
Addition. So there's your operation right there. It's addition. We've got a variable, an operation, and then we've got a number. Notice you always have to have a variable. If you don't have a variable, it's not an algebraic expression. If I just wrote down the number 2, that's not an algebraic expression. We call that just a numeric expression. Algebraic means it has to have a letter. So they all have a letter. Look at this last one. 8x minus 3y. What's the variable there? But Nate, can you tell me one of the variables in that box? Yeah, x is one of them. And what about, what's the other one? Savannah? Y, there's 2. So 1 or more. Can have 1 or more. This one has more. It's got 2 variables. What's the operation in that box? Yeah? There's subtraction. I agree. There's a minus. Is there anything else? Yeah?
Well, if you had if you had a number before it, you would have to do order of operations and time that number by the number inside the parentheses.
So we'd have to do times, right? There's times right there. 8 times x minus 3 times y. So this has more operations. Okay? It's got multiplication and subtraction. How about if I put down 4 plus 7? Is there an operation there?
Addition.
Yeah, there's addition. Is it algebraic?
No.
No, it's not algebraic because there's no letters. Okay? So that's an algebraic expression. It doesn't mean you can get an answer. Like if I said to you on a test, here's the problem, x. What's the answer? No. There's nothing you can do. We don't get into actually finding an answer until you start putting an equal sign. Once you throw an equal sign into the problem, then you have to figure out an answer. Okay? So an algebraic expression, there's nothing to figure out. Just that's what it is. All right, so the next one. It says to blank, 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 we plug in each variable with a number. Anybody know what that's called? When you plug in a number for a variable. You could actually kind of say it in one word, even though there's 3 blanks there, but it begins with an E. And you plug in a number for a letter. Like if I said to you, okay, I want you to take and plug in 3 for x in what I just circled, and do out the math and tell me what you would get. There's a name for doing that. Yep.
Exponent?
Not exponent. Yeah, it does begin with an E though, yeah?
Evaluate.
Evaluate, exactly. So to evaluate an expression basically means take whatever letters you have, the directions will give you numbers, fill in those numbers for the letters. Okay, and this will be our first example that we go through together and we actually try and evaluate something. Okay? So throughout the year, you're going to see directions on a test that may say evaluate. You might see directions that say solve. Very different directions. Okay? We'll talk about what it means to solve something, but evaluate means your answer is going to be a number. You're going to plug in, you're going to do a little arithmetic, and you're going to get a number. All right, so under the examples, what we usually do is we leave the example blank. You guys have to copy down the example from the board.
And guys, if it's like something like that, where it's just like numbers and letters, we'll have you write that down. It's gonna be like a word problem or something like that. When you have to draw something, we would probably give it to you, but it'll probably be on there.
Okay, so first thing, why is that an algebraic expression? Because you can only evaluate something if it's an algebraic expression. What does it have in it that makes it algebraic? How about Nijat?
It has the x next to the number.
Yeah, it has an X and it has a letter in it. Okay. They're giving us two letters in this case. Now, I don't see a plus sign or a minus sign. What operation would we just say that this is? You can do it with parentheses, you can do it with the dot. We just talked about that. Yeah, Jill? Yeah.
Okay.
So, still remembering the names, but yeah, multiplication, good. So, that's multiplication. So, if we were going to pronounce that, it's 2 times x times y. Now, they're giving me some directions. What do they want me to plug in for x? Yeah, Yusuf? Yeah.
4.
Yeah, they want me to plug in 4 for the x, and then what about for y? What do they want me to plug in there? Seamus?
3.
3. So they want me to plug in 3 for y. So our first step is just to copy it down, change x to 4, and change y to 3.
Guys, does someone want to take the risk and tell Mr. Hager how he's going to write that? Like specifically how he's going to write that? Kelly?
So you have to plug in the 4 and 3, so it's going to be 2 in parentheses 4.
Okay, yeah. So we can put, yeah, I messed up. So 2.
And yeah, and plus, I believe,
Is there a plus sign there, Kelly?
no, you just multiply by 3.
So
So yeah,
what's he going to write?
multiply by 3.
How do you show multiply by 3?
Oh, parentheses.
There you go.
Yeah, I could put parentheses on the 3. I don't have to, it's up to you, but if you don't put parentheses, to me that just looks like the number 243. Now, we're going to get into the order in a little bit, but we just multiply, and we just do it in order from left to right. So we start with 2 times 4. Okay, let's just do that one step first. So Alex, can you tell me what that would come out to?
8.
Yep. So 8. Now, did we do anything with the 3?
No.
No, just bring it down. And again, you still have to put parentheses, because if you don't, to me, that looks like you're telling me the answer is 83. That's not what we want. So our last step is 8 times 3. And how about, Miguel, what does 8 times 3 give me?
32.
That care about 8 times 4.
Oh. 24.
24. And that's it. So evaluate means you're going to get a number for an answer.
And guys, what does it mean if you have a number with a, someone tell me, what does it mean if you have a variable or number with a variable right next to it? What math operation is that showing or representing or expressing?
He's talking about what we,
Yeah.
what can you just say right there?
Again, to understand, we have nothing, not so much for this, it seems basic with this, but as we get further on to the year, you're gonna need to know that, because you'll need to know like the opposite operation to use to solve something like that.
All right, so the next thing, this starts to come up when we look at word problems. Different ways, a lot of people have said, oh, plus is an operation. Well, that's one way to say it, but there's different ways to write the same thing. So, what's one way you could read that? The X, that thing in
That's
the
probably the
symbol.
most basic way you would say that. Yusuf,
X plus 28.
X plus 28.
Yep, x plus 28. Can anybody think of another way you could read that? Yeah.
20x.
So that would be times. We're going to get to times like 16x, so we're going to get to that, but not yet for this one. But we'll get to that. Yeah?
28 plus X.
Yeah, that's true. You can switch the order. How about x increased by 28? Right? If I said to you, I want you to increase something by a certain amount, increase means to add to it. I want you to increase, you know, the person's salary by $2 an hour. So increased by. Okay, so let's just take a look. So x plus 28, you guys said that. 28 added to x. I think someone kind of said something like that.
Increased by, you talked about that.
Yep, increased by. Sum. Okay, how many people have heard the word sum before? So if I said to you, all right, I want you to find the sum of all the ages of everybody in here. That means you would add up everybody's age. So sum, more than. So if I said to you, tell me what 3 more than 10 is. If you went 3 more than 10, you would go, oh, 10 plus 3, 13. So plus, added to, increased by, more than, and sum. So now that you've seen those phrases, if you just think of the opposite of all those phrases, that's all the ways you can do the one below. So what do you think the first one would be with that, the next row down? I don't want to say the row because that'll give you the hint at one of the ways to say it. Any thought? Yep. Savannah?
42 minus x.
Yep. 42 minus x. So she kind of just did that way. How about the next one? Yeah, you said?
42 decreased by X.
Yep. So that's gonna fall into this one.
The opposite of that.
42 decreased by x. How about this last one? What's the opposite of sum? When you subtract two things, you call it
Find the what?
Difference?
a difference. Yeah. So I think we've hit a lot of them. They're not in the same order. But 42 minus x. You guys said that one. Difference. We did that one. The difference of 42 and x. I don't know. Did we say decreased by 42 decreased by x?
Yeah.
Yeah, this and that.
This one gets a little tricky.
Yeah, when it's subtracted from or, yeah.
When you see the phrase subtracted from, it's in reverse order.
Or even less than, Mr. Hager.
Yeah, it's in the reverse order. So like if I said to you, and I like to think of it with numbers, if I said to you, what is 2 less than 10? What number is 2 less than 10? Yep. 8. So how do you get 8 with arithmetic? With 10 and 2.
How would you set that up as an actual problem to get 8?
10 minus 2.
Yep. Notice what happened? The 2 was at the beginning, but he put it at the end. The 10 was at the end, it goes to the beginning. So when you see the phrase less than in subtraction, it's going to
Yeah,
switch.
so guys, for these type of situations like subtracted or less than, the order matters. All right? And we talked about here, we could say x plus 28. It wouldn't matter. You get the same answer. All this stuff when we're talking about addition, when we give you a phrase, it wouldn't matter. You could do it either way and get the answer. You could do 28 plus x or x plus 28. Here, the order matters, depending on what type of phrase you're given.
And it's a little tricky because sometimes the phrase you don't have to change the order, like 42 decreased x. 42 decreased x, it stayed in the same order. The 2 I put the box around is when it switches.
And you'll see, like, when we get to word problems, you'll see less than quite a bit.
Yeah. So you got to remember that phrase, the order matters. It's backwards. How about the third row? How could you say 16 with an X next to it? How about Matt?
16 times X.
Yep, 16 times X. How about, what do you call it when you multiply two numbers together?
Yeah.
Like 2 times 3 is 6. 6 is the what of 2 and 3? Yeah?
The product is 16.
Yep, it's the product. So, the product, we did that one. The first one we did, 16 times X, and 16 multiplied by X. So not as many ways on that one. Okay, and how about the last one? What operation are we doing there? Yeah, Ellie?
Division.
Division. So how could you, what's one way you could say that?
8x divided by 18.
If it was flipped, we could say it that way,
That's on the top.
but this one, the 18 is on the
So
top.
it would be 18 divided by x.
18 divided by x. Does anybody know what you call it when you divide two things? 10 divided by 5 is 2. 2 is the what? Yep,
The quotient.
the quotient. Yep. And actually, that's it. Those are the only two ways we have. 18 divided by x, the quotient of 18 and x. I don't really think you'll see many other ways. X divided into 18, but... So now, using those phrases, we're going to practice actually writing one of these ourselves. So it says the cost of P...
You guys, you don't have the examples for these, so you actually have to, it's not a long sentence, you just have to write it out.
The cost of P pounds of tomatoes at 79 cents per pound. Does anyone have an idea of what operation you're going to use here? You're going to buy P pounds, and it's 79 cents for every pound. Yeah?
Multiplication.
Yeah, you're going to use multiplication. It's kind of like if I told you gas is $3 a gallon, you're going to buy 20 gallons of gas. How would you figure out how much it costs? You're going to multiply. So what symbol can I use to represent multiplication? Yeah?
A dot.
I can use a dot. So I start with a dot. And what are the two things I'm going to multiply?
P and 79.
Yeah, P and 79. That's perfectly fine. Now, since I have a letter next to a number, do I need the dot? No. So if I wanted, I could put P79. That's fine. What could I do 79P? Is that the same thing? What do you think? If we multiply two things, does the order matter?
No.
Like 2 times 5, 5 times 2? No. So any one of these is fine. I would just leave it the first way.
Yeah, we have the P79 and the 79P. Which one would you probably see more, what would you see all the time on like a homework or a test or something like that? How would you see it written? P79 or 79P?
79p.
79P, you're always going to see the number first. If it's showing, if it's a variable attached to a number, the variable will always be second. The number is always going to be first. All right?
Okay. So looking at B, y years less than x years. Let's just first figure out what operation are we doing there. Then we'll worry about if we have to figure out order.
Subtraction.
We're doing some kind of subtraction. So the question now is it y minus x or x minus y? Let's look at the phrase. To represent subtraction, they use less than. Let's go back up and see if less than was one of those we did with a box around it. Uh-oh, it was. Whenever the box is around it, here x was first, 42 is at the end. But look at the way we wrote it here. 42 is not at the end. So knowing the order here is one of the ones where it's backwards, how do you think we're going to write y years less than x? Yeah, x minus y. Exactly. Like if I said to you, 2 years less than 10. Okay, I know I used that example before, but 2 less than 10 is 8. So 2 less than 10 is 10 minus 2. Order gets switched. Last one. X increased by 14. Melanie, what operation do you think we're doing there?
Addition?
Yeah, we're doing addition. And now we're taking x and increasing by 14. So Laurel, could you tell me how I would finish that off?
X plus 14.
Perfect.
Is there another way that Mr. Hager could write it? Anybody think? Savannah?
14%.
14%.
Yeah.
It works either way.
Okay, so any questions on the front page? Okay.
All right, guys, when I talk about, there's like a little acronym that we follow for order of operations. Like NFL stands for like National Football League. NRA, National Rifle Association, all that different stuff. All right, but there's a acronym we follow to do order of operations. Does anybody know what that is? Ellie?
PEMDAS?
PEMDAS, correct, right? So that's what it's going to be. All right, so I scroll down here. Again, so each letter, obviously, like we said, NFL, N stands for national, F stands for football, L stands for league, right? The P in PEMDAS is going to stand for what, Dylan?
Parentheses.
Correct, good man. All right, P will stand for parentheses. Anything that's inside the parentheses, you want to do first. And there may be more than one operation going on inside those parentheses. It's kind of like a problem within a problem. Do the stuff in there first. Once you do the stuff in there first, the parentheses disappear. You're done. All right? So P stands for parentheses. E stands for what? Donovan?
Exponents?
Exponents. Good. Can somebody tell me in basic terms what an exponent is? Just very, very general. If I had a problem, how would I know where the exponent was, or if there was an exponent? Donovan?
There would be a little number.
Yeah, it's a little number, right? A little number to the right of a bigger number, or a little number to the right of a variable. We could have something like this. It might be attached like this, 5 to the third, x to the second. It might look like that, right? So those are your exponents. So like Donovan said, the little numbers, all right? So we got parentheses, we got exponents. M stands for what? How about Catherine? What's the M going to stand for in PEMDAS? Multiply. Good. M is multiply. How about Nathan? What's the D stand for?
Division.
Division. Good man. Now, when we get the multiplication and division, remember, we'll do a problem that we have to solve using order of operations. We'll do it just like we read a book. Read a book left to right. Same thing here. We're going to do a problem left to right. But if you have, say if you're going left to right and you had division coming before you had a situation where you had to do division before multiplication, that's fine. They kind of hold equal weight. Whatever comes first when you get to the multiplication and division part, whatever one comes first is what you'll do. You're not going to say, well, I'm going to skip the division because it says in the order, multiply first. No. those hold, and multiplication and division hold equal weight. So whatever one comes first when you get to that part, you can do. Alright? A is going to stand for what, Mary?
Addition.
Addition. I'm getting good with my names here. A is addition. And then last thing is going to be what, Jake?
Subtraction.
Subtraction. Good man. We got S for subtraction. Same idea. Alright? The addition and subtraction. As you get to that point, if subtraction comes first, that's okay. You can do it. Alright? Same idea. They both hold equal weight, just like multiplication and division. But if you do subtraction before multiplication, then you made a mistake. Alright? So the multiplication and division are kind of bunched together. The addition and subtraction are bunched together. They hold equal weight as you do in a problem like that. Alright? Everybody's good with this? I can scroll down. Speak now, trouble, hold your peace. Okay. So now, simplify. What were some of the directions we've had so far? We had the example, then it told us what to do next to it. What was one we've had so far? What was one term we've had so far in the directions? Done it?
Evaluate.
Evaluate, right? Nicole, what's evaluate mean? Yeah, you're gonna plug in a number for a letter, and you're gonna get a nice one number answer. 24, 5, -2. You get a nice number, right? It's one number, it's an answer, it's done, it's plain, simple, easy, right? So evaluate, plug in a number for a letter, get a nice answer. Simplify, what's that mean? Anybody know? I make it something that looks like this. I might get something like that. It says to simplify. Yusuf?
You're gonna add like the two common ones.
And when we get that, these are like terms, so we're going to combine them. You get 7x plus 2. Alright? Can I combine these two things? No, I know we haven't talked about that yet, and we will in a few minutes. But again, we can't. So basically, does anybody want to take a shot at what simplify means? What you think your definition of simplify might be? Dylan?
To like combine like terms.
Yeah, you're going to combine like terms, and then what you're going to basically, when I think of simplify, you're going to go as far as you can. Once you get to, like Dylan said, once you get to a spot where you can't combine like terms, you're done. Yusuf, what were you going to say?
I was gonna say you can like after you're done like combine like terms like rewrite the problem.
You could do that, yes. You definitely want to do that. I just don't want to circle these two things and have this as my answer, because it doesn't show me that. So when I think of simplify, alright, go as far as you can. If you want to write this, you can. If you don't want to, you don't have to. It's up to you. If you feel it.
What does that say?
Go as far as you can. Answer may be more than one number, I should say. Is that good, mistake? Still getting me after all these years. So go as far as you can. I went as far as I can. I can't do any more. Answer may be more than one number. Here we had 2 or a variable. You might have like 2x plus 3y minus 3. Right, so the difference between evaluate and simplify is evaluate, that'll be a nice answer. One number. Simplify, it might be kind of nasty. It might, because a lot of times kids will make mistakes saying, look at all those numbers there. Like, my answer should just be one number. It's math. Again, it depends on what the directions are. It says to simplify. If you have different terms, non-like terms, you're good, right? Simplify means go as far as you can. Your answer may not be nice. It may not look nice. Let's put it that way. All right? So here, it's asking us to simplify. Again, we may get like a fraction as an answer. We may not be able to do any more than that. All right? Okay, so let's look at this. Someone tell me, where am I going to start? On the top or on the bottom? Someone raise their hand and tell me.
On the top.
The jelly, right?
Yeah.
On the top or on the bottom?
Top.
Where would you start? Based on what? Based on the different thing, the different symbols and stuff out there. Where would you start?
I start at the bottom where the parentheses are.
I would start at the bottom of the parentheses. Yes, I would definitely do that. And we're going to do what's inside the parentheses, right? When I do that in jelly, what do I get?
3.
5 minus 2. Alright? I'm not going to do any more than that. I'm just going to do that piece, and I'm going to move on to the next step. 5 minus 3 is 2. Remember, once you do what's inside the parentheses, they're gone. They disappear. Alright? I'm going to bring over the second power. Alright? I'm going to bring all this stuff on the top. I'm just going to bring it over. I'm going to go step by step. Some of you guys may be good enough to say, yeah, okay, I'm going to do the top step now too. That's fine. Alright? If you feel comfortable enough to do that, great. I've been doing this 5 years with Mr. Hager. I still don't feel that comfortable yet. I'm going to write out every step. This is how I am. My wife will probably yell at me and say, just do it, but I'm not gonna. Alright? So now, what am I gonna do next? Donovan?
Exponents?
Exponents. How many sets of exponents do I have?
3.
3, right? I got this, I got that, I got that. If I was gonna read this, 2 with the little 3.
2 to the third power.
2 to the third power. You're gonna say something. That means 2 to the third power. 4 to the second power. 2 to the second power. Or you could say 2 to the power of 3. 4 to the power of 2. What does, Nathan, what does 2 to the power of 3 mean?
2 times 2 times 2.
Yes, good. So, newsflash. 2 to the third power does not mean 2 times 3. I guarantee you, when we get to doing exponents, people will do that. But just as a heads up, as a friendly reminder, 2 to the third power does not mean 2 times 3. You're taking the big number and multiplying it to it's the one time where the little guy's going to be in charge. The little guy's the boss. The little guy is telling the big guy how many times he's going to be multiplying together. So 2 times 2 times 2, and I do that, I think the person said 6. I'll bring my plus sign over. Alright? How about 4 to the power of 2? 8, right? No. Ellie, what's it going to be?
16.
16. I'm doing that just to show you, don't make the mistake. It's not 4 times 2. It's easy when it's like 2 to the 2, if you think of it that way, when it's 2 to the second power, it's like, okay, it's 2 times 2. It'll work out in that case. In most other cases, it won't. Alright? On the bottom, what am I going to get? Page 4 to the power of, 2 to the power of 2. 4. Seamus, don't laugh. Say, what's wrong? Oh, I did screw that up. I wrote the wrong thing, didn't I? What should I have wrote for that?
9.
8. Sorry about that. Alright, now, what can I do? What do you think, Savannah?
Add 16 plus 8.
Yeah, I can't, I know division comes before, addition, but I gotta do this first before I can divide. Alright, so 8 plus 16 is what? 24. Bring my sign, 4. Final answer is gonna be what, Chris?
6.
6. Yes. That's a 4. It's a really bad 4, so I'm mistaken. And it's going to be 6. Final answer. Again, in that case, when I simplified it, it worked out nice. It worked out nice because I didn't have any variables. Now, evaluate. What am I going to see now? What am I going to see now in this problem that's going to be different than the problem I did before this? Matt?
Variables.
I'm going to see some variables, right? I'm going to see some letters. But what am I also going to get besides those variables? That's going to help me to solve. Mary?
Number to put in the variable.
Yeah, it's going to tell me what those variables are going to be worth in that particular problem. All right? So again, we know evaluate means we're going to plug in. When I evaluate, what's my answer going to look like? Will it be nice? Will it look nice? Huh? You think yes, Yusuf? Yeah, you said I disagree with you. Evaluate's going to be nice. Because you're going to have, when I set this up, I'm going to have all numbers plugged in. There'll be no variables. They'll be all gone, so I can just solve. Alright? So remember, evaluate, you're going to get a nice number for an answer. Okay? So let's write it out. Alright? So I'm plugging in, for x, I'm going to put 4. Alright? So let's do it. Let's look at this first part. Let's do this. 3x to the second. How would I write that out? Somebody want to tell me? Ellie?
3 and then 3 times 4 to the second power.
How could I show 3 times 4? I don't want to just put 3 and 4 because it's going to look like 34. I don't want to do that.
Put a dot.
I could do a dot. What else could I do?
Parentheses.
Alright, well, let's do, for this case, Ellie, we can do a dot, that's fine.
Alright.
I wouldn't recommend it all the time, but for this it'll work. And then we also have to put, Ellie, one more thing.
The variable of 2.
To the second power. Good. Make sure I put my minus sign. How am I going to write that next part? Yeah, Yusuf, go ahead, buddy.
It's going to be minus 2 and then 2x, which you said all x equals 4, so and parentheses.
You want to do parentheses? We can do a dot here, we can do parentheses there, that's fine. As long as you know what it means. I'm going to put my plus sign, and what's the last thing I'm going to write? I got everything set up, but now everything's plugged in. This is like 2 steps. I had to plug in the numbers, and now what am I going to use to solve this? What would I use? We just talked about it. Matt?
Order of operations.
Order of operations, otherwise known as PEMDAS. Alright, so what am I going to do first? Yusuf? For the second power. I know I have a parenthesis here. I understand that. I only really need to do the parentheses because this is this over here. This is this basic multiplication. Alright? There's one term here, one term here. I'm only going to do parentheses when there's more than one term inside the parentheses. In this case, there's only one term. It's basic multiplication. I'm not going to do that first. So like Yusuf said, and I agree, I'm going to do my 4 to the second power, which is what, Yusuf? 16. Everything else I'm going to write out. So I'm going to put 3, put my dot, 16 minus 2 times 4 plus 1. Miguel, now what?
3 times 16.
3 times 16, right? Again, I got double multiplication. Do it left to right. Whatever comes up first is fine. So 3 times 16, you know what that's going to be, Miguel?
It's going to be
42 mistaken, am I right?
48.
What is it mistaken?
48.
48. 48. At this point where I have the double multiplication, I'm going to do it all in the same step. Alright? So I got the 48. Now this is a little tricky. We haven't really talked about this yet. I have a, actually I can do the negative 2 times a 4, am I mistaken? So I'll do a negative, I'm doing a negative number, we'll talk about this more tomorrow, but again it's good to review. A negative number times a positive number. What's my answer going to be? Negative. And we'll talk more about that tomorrow. We get a negative, then we'll just do 2 times 4, which is what, Jake? 2 times 4 is what? Not sure, I caught you at a bad time. Sorry, buddy. How about Seamus? 2 times 4?
2 times 4 is 8.
Awesome. 8 plus 1, alright? Again, now I'm at addition and subtraction. Again, whatever comes first I can do. Chris, let's do 48 minus 8.
40.
40. I got 40 plus a 1. Final answer, everybody, is 41. So again, that was like 2 steps. You had to plug in the numbers and then do order of operations. Alright? Alright, so you guys may have seen this before, distributive problem. So on your notes, you have a spot to put, to write it again. Sometimes when we're like doing definitions or writing out steps, we may write down what you have to define, but then after that will be blank because we're going to go over the definition together, like we're doing right now. So for the distributive property, the number on the outside of the parentheses, again, there's some cases where the number every once in a great while might be at the end. All right, it might be like, I'm going to have parentheses, and then I have like a 2 here, and nothing in front. All right? Every once in a great while we'll see it. For the most part, it'll be a number outside the parentheses, 2 plus 5. It'll be like that, or like that. So we're taking the number on the outside, and we're going to multiply it to each number on the inside. All right? So like in this case, I would be doing positive 2 times positive 2, and then positive 2 times positive 5. You might see like, I know Mr. Pelletier, who I teach with downstairs, he sometimes calls it like the claw. You're going to claw it. All right? So, this one says solve using the distributive property. We're solving, which means we're going to get a nice answer, one number. All right? Give me one thing I'm going to multiply. And make sure you tell me what type of number it is, positive or negative. Ellie?
Oh, you're gonna multiply 7 by 8.
Positive 7 or negative 7?
Positive 7.
Times,
Positive 8.
and I get
56.
positive 56, right? But I can just write 56. Big thing is, guys, you always want to make sure, we haven't talked about this yet, you'll hear me say it all the time. Number to the left tells me what type, sign to the left is going to tell me what type of number it is. Meaning, is it positive or if it's negative? Here, oh no, there's no sign. If there's no sign, we know that it's what?
Positive.
Positive. It's just the way it is. All right? If there's no sign, we know it's positive. All right? We can get away with not writing a sign there because, again, it's the beginning of the problem. We're not going to be really doing anything to it. So I did the 7 times, positive 7 times positive 8. How about, what's your name? Can I forget? I'm sorry. Yes. Bethany. Bethany, what am I going to do now? What two numbers am I going to multiply together?
7.
Are they both positive? Yes. So we're doing a positive times a positive. What do I get? No. Positive. Only negative times a negative will turn to positive. Alright? So this will be positive. And then 7 times 5? 35. Again, here, if you just wrote the number, it's not going to tell you what you're going to do. You're adding and subtracting. So now we know we're adding. All right, Ms. Hager's going to write the answer for us. 56 plus 35 is 91. All right? So now it's saying, so again, that's this distributive property. And again, if we had something like 3 times x plus 2, we do 3 times x, which is what? 3x plus 6. Yes. All right, so we're examining this. 7x plus 13xy plus 18. The parts of an expression connected by addition and subtraction are called what?
There's 4 of these in the school year.
Terms. Terms, right? So those are going to be your terms, all right? Now 18, I know 18 is a number, but 18 won't change. 18 is 18, we're not changing it. So it's a what? Doesn't change at all. None of it? Constant. Good. 18 is going to be a constant or a constant term. So on your notes right now, guys, you're filling in those blanks. So the first blank would be terms. Second blank, you had 2 blanks actually. It would be a constant term, all right? Or just a constant, all right? Because it can't change. There's nothing attached to it that's going to make it change. All right? Anything else?
I think that's good.
All right. So guys, that's good for today. We'll do a little. No, actually, I'm not done with that. Not the worksheet, but the.